The graph of an equation is sketched below. So there's two things we're going to do here. First, we're going to create a table of ordered pair solutions of this equation. Your table should include at least 5 ordered pairs. Then we're going to find an equation of the line. The hint is to recognize a pattern from the table you create in part A. So let's see what we can see from our graph here. So we have a graph. First thing we want to do is we want to come up with some ordered pair solutions to whatever this mystery equation is that we're trying to find. So let's find some ordered pairs that fall on the graph. So it looks like there's an ordered pair, and there's one, and there's one, there's one, and there's one. So there's lots and lots of ordered pairs that we can choose from. Okay, so I'm just marking a bunch of them that are easily read. Now remember, all of these little fractional values in between would also be potential solutions to the equation, but we're just going to find the ones that are easy to read. So I need at least 5, so let's go with 5. So I'm just going to circle 5. I'm going to do that one, I'm going to do that one, and that one, and that one, and then I'm going to grab this one down here. So I could choose any 5 of the ones that I had marked there. And I'm going to start up here at the top and just work my way down the line. So this first point, if I start at the origin, I go over 4 in the x direction. Here's my x-axis, and here's my y-axis. So I go over 4 in the x direction, and I go up 8 in the y. So when x is 4, y is 8. Now when I do this next point here, from the origin, I go over 2 and I go up 4. So when x is 2, the y is going to be 4. So I've taken care of that point. I've taken care of that point. And now let's do this one here. In the origin, I go 1 in the x direction and 2 in the y direction. So 1 in the x and 2 in the y. Then notice that this one goes right smack dab through the origin. Remember that the origin, the ordered pair for that is 0, 0. And then finally, I've got this point kind of down here. So from the origin, we go -4, no, we go -3 in the x direction. We go -6 in the y direction. So -3, -6. Now we have to find an equation of the line. And the hint is to recognize a pattern from the table you create in part A. Now, it may very well be that as you were writing down those ordered pairs, as we were talking about those through, you were seeing the pattern already. We went from 4 to 8. And at first we might say, oh, well, I'm adding 4 to each value of x. But notice that that doesn't hold when we look at going from 2 to 4. That pattern doesn't work. So it can't be adding 4. How else could I get from 4 to 8? Well, I could multiply by 2. Does that work here? If I take 2 and multiply by 2, I come up with 4. If I have 1 and I multiply by 2, I end up with 2. So notice each one of my x's is getting multiplied by 2. Let's see, make sure that that holds out for all of these. To get from 0 to 0, yep, sure enough, multiplying by 2 is going to do that. And even with the negatives, from -3 to -6, when I multiply by 2, that takes care of it for me. So what would be the equation of the line? Well, for any y, how do I get my y? I take 2 times the x value. And so that would be the equation of that line. So now we can work these problems both forwards and backwards. If I'm given an equation, I can graph the line. And if I'm given a line, I can come up with the equation that gave that line to me.